Hello there, and welcome to day 78 of the 100 Days Python Programming Challenge. And what is the topic for today? Today's topic is stacks and queues. Today, I would show you how you can use Python list as both stacks and queues in Python. I'm excited. Are you excited? I'm excited. Be excited. It's 78, day 78. Day 78. Hello, everybody, and it's day 78. 78 of the 100 Days Python Programming Challenge. Topic is we're using lists as stacks and queues in Python. So, in the Jupyter Notebook, I wrote a lot of explanation so it can help you understand it while you're coding. So, what is a stack? A stack is a data structure that follows the last in, first out principles. This means that the last element added in the stack is the first to be removed. So stack, you're putting it on top of each other. The last will be the one on top. It's the first that you remove. And then the operations that you can perform is that you can add an item to the top of the stack. You can remove the item from the top of the stack. You can view the item at the top without removing it. And you can check if the stack is empty or not. I put a picture so you understand. So this is an empty stack, and then we are putting it on top of each other. The last one is the first to leave. So stack on top of each other, and then the last is the first to leave. And we'll also talk about queues. But first, let me show you stack, and then we'll come to queues. So stack would have a list. So I have stack first, my empty list. And then I want to add items to my list. And my stack, also my list. So how do I now add it? I will use the append method. So if I want to add 10, for example, I would have stack.append 10. If I want to add more to it, I can add 20, for instance. So stack.append 20. And if I want to add again, I will add another one, which will be stack append 30. So now I've added my stack. This is the first element in my stack that goes to the bottom of the stack. This is the second, 20 is the second, and 30 is now the third that stays at the top of the stack. So operations that you can perform, for example, is to remove the top item from the stack, the top item from the stack. And how do you do that? You use the pop function. The pop-out function removes elements from the end of the list. That means the top of the stack. So I would have my variable name top item equals to stack dot pop. So by using the pop, it removes the top element. And what is the top element? The last thing that I appended, which is 30. Remember, it is last in, first out. So the last element that I added is the first that would be popped. So if I have this and then when I run this, we see that the popped item is 30 because that was the last thing that I added. Then what if you want to view the top item? I want to view the very top item in my stack. How do I do that? I use stack. Let me show you. It's just like if you want to learn about list, there's a video on list that would help you to understand this better. So I'm starting from the back, from the hand. That's why it is -1. And I want to print the item in the top of my list. Remember that I've already popped 30. So 30 doesn't exist anymore. So the top item now is 20. I would say top item is 20. So this is how you're able to like pop and able to print the top item by taking stack. What is stack? The variable name for our list, and then -1 because we want the very end. If we want the first item and not the top, and I run this, you see we have 10, and -1 gives us the top item. So the next thing that we might want to do is to check if we have an empty stack or not. And how do we check if we have an empty stack? We will want to check if the length of our stack is equal to 0. If it's equal to 0, then that means that we have an empty stack. But do we have an empty stack? No, we do not, because we still have 10 and 20 in our stack. So when I run this, you see our stack is not empty because we only popped 30. We'll still have 10 and 20 in our stack. So this is how you use pop, how you're able to fetch item from your stack, and now you're able to check if your stack is empty or not. So you see, we push value onto the stack by using append, we pop value, we remove by using pop, and we view using indexing. And you can also check if the stack is empty by checking the length of your list. So now let's go to queues. What is a queue? A queue is a data structure that follows the first in, first out principle. Stack follows last in, first out principle, but queue follows first in, first out principle. This means that the first element that you added to your queue is going to be the first element that will be removed. So first element added, first element removed. So the operation that you can perform is you can add an item to the back of your queue, you can remove an item from the front of your queue, you can view the item at the front without removing it, and you can also check if a queue is empty or not. And how you can do that is by also doing append. You can use pop, and you can also view by using indexing, and also check if it's empty or not by using the length. The only difference is the order. The order you use, the order for stack, last in, first out. The order for queue, first in, first out. So now let's have our empty queue. This is my empty queue. And then let's add uh, items to our queue. So the exact same way we added it for stack, we have queue dot append. We've added the first one, and then the second one 20, the same way we did for stack. And then the third one, we have 30. And then now, how do we now pop item, removing item from the front of the queue? Here we just use simply pop and pop the last item. In queue, you can't just use pop because then it will just still pop the last item. We're going to put an index. So the first item, because we want first in, first out, the first item is going to be index 0. And when we want to pop it, you use q dot pop and then the index inside a bracket. And then when I run it, we see that this is the item. And we see that this is the item that got popped. And now let's print out our queue so you see the rest of the item in our queue. You see, we have just 20 and 30 because 10 got popped. In our stack, you see, we popped 30 and we had 10 and 20 left. So that's the difference. When you're dealing with stack, you just use stack.pop. And when you're dealing with queue, you have to specify that you want to pop the very first item. Okay, so next thing that we want to do is, what if you want to view the first item? That is the item in the front, not on top of each other like stack, but lined as a queue. So we would have our queue and then we'll specify the index. And when I run it, we see that our front item is 20. We already popped 10. Our front item is 20. And then to check if the length of our queue is equal to 0, that is if we have an empty queue. The same process we did for stack, we'll check if the length is equal to 0, and then we'll print either true or false. But then my length is not equal to 0 because I still have 20 and 10. And when I run this, we see that it is not true. So then what are then the difference between stack and queue? The last in and the first out, that is for stack. The first in and the first out, that is for queue. To add item, you use append. You also use append for queue. To pop, to remove, you just use pop. But for queue, you have to specify the index or you use pop left. And for efficiency, it is O of 1 for both pop and queue, while it is O for 1 to append and O of n to pop. And then you can undo operation. You can use this for your depth first search, and this one you use it for your breadth first search. Maybe I should make a video about depth first search and breadth first search. Let me know if you want a video about that. So that is what we've talked about today: stacks and queue. First in, first out, last in, first out. See you tomorrow for day 79. That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions. And as always, the link to the Jupyter notebook is in the description. See you tomorrow.